This problem is tough enough that I thought I should record a video, and it doesn't look like it's randomized, so I'm basically showing you how to do this question, okay? And that's okay. It's a tough question. What makes it tough is trying to simplify it so to get to something where you can integrate it. I notice it is a definite integral because it's got the bounds, so we're going to get the number. The answer is going to be a number, not an equation, not an indefinite integral. So first off, we're going to get this so somehow how we can integrate it, because at first glance it's not. So there's a lot of different trig substitutions you can do, and I tried a few of them. Then I stumbled on this one. But the first thing I did was I wanted to get rid of the secant. If it was a secant squared, it'd be a piece of cake, because we know the antiderivative of secant squared is tangent, but that's not what it is. So what I did is I wrote this as cosine x plus 1 over cosine x, because secant's the reciprocal of the cosine. And then this is over 1. And so I got to get a common, I want to make this be one fraction so that I can combine them and do some work with that. So I'm going to multiply by cosine x over cosine x, because this has the cosine x in the denominator, right? So that leaves me cosine squared x plus 1 all over cosine x. And this is being squared. So then, since it's a fraction, a rational expression, I know I can square the top and square the bottom. So cosine squared x plus 1 squared over cosine squared. Okay, so now what we want to do is expand this out. So this is just like expanding x squared plus 1. Now, if you remember that, think about that. If I'm squaring this, that's the same as x squared plus 1 times x squared plus 1. So x to the 4th plus 2x squared plus 1, right? Because we get the outside and the inside. We'll do that same thing here, only with a cosine. So that becomes cosine to the 4th x plus 2 cosine squared x plus 1. And now this is all over cosine squared. So I can just break these out to 3 different fractions. And that does some nice things for us. So cosine x to the 4th over x squared is x squared, right? So this is just going to become cosine squared x plus, down here the cosines cancel out, so plus 2 plus now 1 over the cosine is secant squared x. So we know that one's going to be easy now. We know that antiderivative is going to be the tangent. But we got to deal with, actually the 2 is easy too, because that's just a constant. What makes this hard at this point is this cosine squared, because how do you find the antiderivative of cosine squared? Well, this is where we need to pull out a trig table, a trig identity table. So if we whip out this our trig identity table, I see these half-angle formulas, or power reducing, right? Because the squared's what's making this be a problem. So let's rewrite this as let's see, this is cosine, so we're going to use this one right here. Now, if this is u, we're going to rewrite that as 2u. So if the x is u, our x is u, we're going to write this as, this part becomes 1 plus cosine 2x, and that's all over 2. And we don't have to take the square root, because that is what cosine squared is. Now, what do we do here? Well, this is, again, one fraction, so isn't that 1/2 plus 1/2 cosine 2x plus 2 plus secant squared x. And I see I can add these two things, right? So that's 2 over 2, 4 over 2. So 4 over 2 plus 1 over 2 is 5 over 2. So now let's bring it back in the calculus piece of it. So we want to integrate this from 0 to pi over 3. And because I'm going to have 3 different expressions here. So 5 over 2 dx because that's the 1/2 plus the 2, right? Plus 1/2 integral from 0 to pi over 3 of cosine 2x dx plus the integral from 0 to pi over 3 of secant squared x dx. Okay, so let's see here. We know the antiderivative of this is 5/2 x. And then we're going to evaluate this from 0 to pi over 3. So 5 over 2 times pi over 3 minus 5 over 2 times 0, right? The mistake I tend to make is I'll forget to do the second part. But because it's 0, we don't have to. I would have been okay. So this gives me 5 pi over 6, right? So that's that piece, 60 and 6. That's this piece of that integral. Just checking my work here, make sure it's what I got earlier. Yeah, that is what I got earlier. Okay. So now for the second piece, the 1/2 is a constant, so I pulled that out in front. So what's the antiderivative of cosine? So what you want to think about here is it's kind of like a chain rule. It is a chain rule. So if I do the antiderivative of cosine, I know that's sine 2x. But if I take the derivative of this, I've got the extra 2, and I didn't have that here to begin with. So I got to make that, multiply that by 1/2. That way, when I take the derivative of this, the chain rule, right, 1/2 cosine of 2x times 2, because of the chain rule, that 2's cancel out, okay? That's the trick. And then, because I've got that other 1/2 out in front, right, this other 1/2, 1/2 times 1/2 is going to be 1/4 of sine of 2x, and I'm going to evaluate that from 0 to pi over 3. So 1/4 times the sine of 2 pi over 3, right? Because pi over 3 times 2. Well, remember that. So over here in quadrant 2, that's a 60-degree reference angle, so that's the square root of 3 over 2. And that's what we want. That's the sine. So we're going to get 1/4 times the square root of 3 over 2 minus 1/4 times the sine of 0, right? Because we're substituting 0 for the other piece. And of course that's 0, so we don't even have to worry about that piece. That all cancels out. So that's going to give me pi over root 3 over 8. Then the last piece, we're going to do the antiderivative of this, and of course the antiderivative of secant x is tangent x. And we're going to evaluate that from 0 to pi over 3. So the tangent of pi over 3, then you got to think about your triangles. If this is pi over 3, that's 60, so that's the square root of 3 over 2, and that's 1/2, and that's 1, of course. So tangent's opposite over adjacent, or y over x. So the square root of 3 over 2 divided by 1/2, which is the same as multiply by 2 over 1. The 2's cancel out. So that's the square root of 3. And then, of course, the tangent will go, what's it, minus the tangent of 0, and the tangent of 0 is 0. So, again, we just got to worry about the root 3. So now let's put all this together. So that's the results for my 3 integrals, right? I broke it all out. So I see some like terms. I see this root 3. So I can think of root 3 as 8 root 3 over 8. And I've got a 1 root 3 over 8. So that gives me 9 square roots of 3 over 8 plus 5 pi over 6. And that's the area. That's the exact area. It is the area under the curve. It is the exact area, or the exact answer for this. Hopefully that helps without giving you too bad a headache.